Hi, in this video we'll be talking about something called parameterized queries. They're ways to interface SQL much more nicely with a given programming interface. In this case we'll be talking about Python and specifically the Sqlite 3 module. So let's make sure that we're comfortable with how to use Sqlite 3 from Python. So the way that you do this is basically you use the execute method. So you connect to the database and you pass in a file name that represents where the database should be stored on the file system. If you pass in the special : memory : you say, hey Sqlite, don't actually make a file to store this in, just keep everything in memory, and then when the Python script is done, just remove it and don't worry about it. It's a way to kind of clean up when you're trying to do a lot of testing. But you generate this connection object here called conn, and you use this connection object to execute SQL queries. For instance, creating a table named students with 2 columns, name and age. So if you want to insert data into this database, well, you execute another SQL query. You execute an insert into statement. So here I'm adding myself, Josh, and age 27 into the table students. However, what if I didn't want to have to write out this SQL query from beginning to end here? What if instead I had data that was already in Python that I wanted to add to the database? For instance, my dog Zoe, she's 7 years old. Perhaps I had to look up 7 from some external resource that Python could see. And now I want to add Zoe into my database, and she's 7 years old. So what do? Well, without using parameterized queries, you would be forced to do something like this. You'd say con.execute, and you'd make a query that has Zoe's age in there. So you say insert into students value Zoe, and then I need to convert that 7 into a string so that I can concatenate it with the rest of my query, and then I need to put the closing parentheses, the closing semicolon. So I'm basically building my string query on the fly as necessary. Now, that's kind of finicky. For instance, converting integers isn't too bad, but what if I wanted to convert strings into here? Well, the problem with accepting strings is what happens if my strings have single quotes in them? What happens if they have characters that need to be escaped before they can be added to the database? Hopefully you learned from Project 1 that escaping stuff for particular formats is a pain, and you guys really shouldn't ever do it. Instead, you should be relying on libraries by people who had a lot more time and effort to devote to this put in for you. So that solution for SQL is called a parameterized query. They're used to pass Python objects into queries without having to manually convert them to usually strings. So for example, my dog, she's 7 years old, and the way that I'd use a parameterized query is I basically write my SQL statement just like I would normally. I would say insert into students values, and then parentheses, Zoe, comma, and then I stick a little question mark. And then I pass another argument to the execute method, which is a tuple of the values that need to get put into each of those question marks. Now, if you only have one question mark, your tuple only has to have one thing in it. It only has to be dog age. And now note that comma there is actually necessary. If you take out the comma, you didn't actually pass in a tuple. You just passed in an integer, and that would break things. And so with this dog age, this variable is getting put into the question mark, and it's doing the converting to strings and escaping and doing all of that on your behalf. However, you can have more than one question mark in a query. For instance, let's say I want to add Tim, who's 45 years old, to my database. So here I say con.execute, insert into students values, and I put 2 question marks here. The first question mark is for the name, in this case it'd be Tim. The second question mark is for the age, in this case it'd be 45. And then I can just pass in my tuple as my second argument, which funnily enough happens to already be a tuple, so that's real easy to do there. So here's something that might sound a little bit off the wall when we're talking about parameterized queries, and that is I want to talk a little bit about SQL injection attacks. So here's a nice little webcomic by XKCD, by Randall Munroe, that talks about using SQL injection in order to cause a little bit of havoc with the database. Now, I want to talk about exactly what went wrong in handling this database input. So the problem is basically the way that the person who wrote the database was working with the input was doing something like this. We're saying, hey, figure out a name, ask somebody to provide a name, for instance, on a web form or reading a name from a file, and they expect the name to be a normal name, with the 26 letters, no spaces, no punctuation. And what they did is they did my pre-parameterized query SQL statements, where I said insert into students values, open single quote, and then at the end I have this close single quote close single quote parentheses semicolon, and then they added their name in the middle. And this would work perfectly fine if people gave normal names like Robert or Josh. But what if somebody gives something like Robert single quote parentheses and just like all this other junk in here? Well, for this particular input, if we actually build the string that would be iterated, it would say insert into students values Robert, and then it would have this close single quote, the close single quote here, parentheses, semicolon, and then it says drop table students, semicolon, and then hyphen, hyphen, and then you add the rest of your string, your closing single quote, parentheses, semicolon. So what does this statement do? Well, it adds Robert to the table. That's great. But it also says drop table students. That's a command that I haven't talked to you guys about. Drop table basically means delete the table. These two hyphen characters are how SQL denotes comments. So it's basically saying, and then ignore the rest of the line. So what this execute does is it adds a student in and then deletes the entire table, which is almost certainly not what was intended. The problem is SQL injection allows you to run arbitrary queries against your database, including queries that are destructive. And how did that happen? Well, the problem is they didn't sanitize their inputs. They got in a name that looked like that, and they should have said, hey, single quotes are not allowed in your input so that you can't do junk like that. Instead, they should have made sure that that wasn't allowed, or they should have escaped all of the escape characters in here, and they should say, oh, single quotes need to be escaped with another apostrophe so that it actually adds the apostrophe instead of interpreting it as part of the SQL syntax. However, both of those are really annoying to handle, and a better way to do this is to actually use parameterized queries. So parameterized queries automatically escape the input and ensure that the appropriate value is stored in the form that you expect. So for instance, if this is our name, the better way to insert this name into the table is to say insert into students values and stick a question mark in there and then provide a tuple, and the name is the one thing that's inside that tuple. And what this means is the string that's added into the table will be stored exactly as the way you want it. It'll be ROBERT apostrophe, I can't even ever say these, parentheses, semicolon, and so forth. And it will store that text exactly the way that you asked it to, and it won't treat the single quote here as ending the text field, and all of this stuff is actually a query to run. So parameterized queries protect you from this problem of having to escape characters that needed to be added to the database. And so this is a really nice feature of parameterized queries, and I strongly recommend you use parameterized queries in almost all the time that you ever need to write insert into statements and things like that, because they're really easy to mess up. The other thing that I want to talk about is actually revisiting back on datetime objects, in that Python and SQLite actually have this nice communication with each other, where Python SQLite 3 module is actually smart enough to store Python's datetime objects cleanly inside of SQLite. There is actually a custom data type called capital DATE in SQL that can hold datetime.date objects, so it can hold a Python object. There's also a custom data type called timestamp that can hold datetime.datetime objects. These are ways to represent these Python objects inside of SQLite. However, the kind of annoying thing, in order to use these automatic conversions, there's a bit of additional arguments you have to pass to the connect method of the SQLite, the connect function of the SQLite 3 module, which I'll show you in a little bit. All right, so here we are in a Python script. I'm just calling it time.py. I'll provide it in the description for the video. This is adapted from the Python SQLite 3 module documentation, so if you want more examples, you can go there. So in order to use datetime and SQLite 3 together, you need to import both of them. And then what I need to do is I connect to, and I'm just connecting to the in-memory file. And you need to pass in these couple arguments. What they actually mean we'll talk about later. For right now, you can just copy paste them from here. And then what we need to do is we need to create a table. So create table named test. It has two columns, D and TS. D here is a date object, and TS here is a timestamp object. Those are the special custom data types that can hold datetime.dates and datetime.datetimes. And what I just did here is I made two example objects. Here is a date, here is a datetime, and I can use the parameterized queries to add in those two objects into my test database. And then the next thing I do is I execute a select statement that just gets out the really only one row in this database. I extract out that single one row because result here is an iterable over many rows. I just get the very first row here. And then I print out today, which was the variable I created here, as well as the first item in row. And I also print out the type of row. And if everything went well, today here should be the exact same thing as the thing I extracted from my database, and the type of the thing I extracted from my database should be a datetime.date object. And this is the same thing for the datetime.datetime object, showing that I was able to create datetime objects, add them to the database, and get them out as datetime objects as well. So I'm going to switch to the terminal and give it a go. Okay, so here I am at the terminal. If I run that file here, I can see, yes, indeed, here is my date for today is a Python object, and here is my date from today extracted from the database, and it did recognize that this is a datetime.date class. I can do the same thing for datetime.datetime object, so here is the current date to the nearest microsecond. And here is it extracted from the database, and it does correctly recognize it as the correct type.